All right, so for this next little unit, we're going to talk about how they are made. Again, the addition of a nucleotide to a DNA strand, I just want to emphasize again, is you have this nucleoside triphosphate. So what happens is here they're showing thymine with one of the phosphates attaching, and then the other two phosphates are being removed. But what I need you to know always is it's going to be on the 3' end. Okay. So let's look at how this happens. Now, what you need to know is DNA replication will have a leading and a lagging strand. And they call it that because the leading strand is built quicker. It's a little bit easier for it to happen. Whereas the lagging strand will take some time, and we'll talk about that. Okay, so let's go back to this picture up here and just make sure that we are looking at things correctly. Here we have the origin of replication. You can see that right there. That's where it opened. This is one of the maybe hundreds of origins that exist on this chromosome. Then this right here would be a replication fork, and then right here would be another replication fork. So there's a couple of them here. Okay, and so here's what I need you to know. The leading strand is always built in the 5' to 3' direction. Okay, so we're adding nucleotides on the 3' end. It's always being built toward the replication fork. Okay, so as this thing unzips, it just puts in one nucleotide at a time, the complementary nucleotide. It's built continuously, which means one after another. There is no breaks. And then it uses one RNA primer to start it. Okay, so you have this continuous elongation, 5' to 3' toward the fork. Everything's working out well. All right, now the problem is the other side. Because if DNA can only be built in the 5' to 3' direction, the problem is the new strand on this side, the 5' will be down here, and it's got to be built in this direction. So there's really two options. One option is just to wait for the molecule to open completely up and then build the other side, or it can build it in pieces. And that is actually what happens. And that's why we call it the lagging strand, because it has to wait for part of it to open. So notice this is not a typo. It's built in the 5' to 3' direction. That is the same as the leading strand. But instead of building toward the fork, it's built away from the fork. So it has to wait a while for it to open up, and then it'll build a piece. What you need to know is those pieces are called Okazaki fragments. And this was because the guy that figured this out was a Japanese scientist and named Ozaki. So the fragments are named after him. What you also need to know is each of these fragments, again, DNA cannot start on its own. So each of these fragments have to have an RNA primer on it. Okay, so they call it, again, the lagging strand because this one's going to take a little bit longer for it to complete. Okay, so it's pretty simple. So here's the overview, and we'll talk about the enzymes in a minute, but in the next video. So here we go again. If you look here, somewhere out here is the origin of replication. Can't really see it. Here's the replication fork. So here's the leading strand on the top with its template. So again, built in the 5' to 3' direction. It has one RNA primer, which is kind of sliding down. And it's built continuously. New three new nucleotides added to the 3' end. Okay, then the lagging strand's on the bottom. So here what they're doing is they're showing you a primer, and then it builds these little pieces. So you can see these little pieces are built, built. And again, built in the 5' to 3' direction. The new strand 5' to 3', not the template. Okay, so hopefully that makes sense. So look at that. And we will stop share and the recording.